We're going to be looking at 1.3a, the average rate of change. What I'd like you to do is go ahead and draw this little chart here, little graph area. We're looking at a company that's selling air conditioning within 3 years. So mark it as 2017, 2018, 2019. And then mark it up, go all the way up to 400. So we're at 100 sold, 200 sold, 300 sold, 400 sold. Okay, so here's our data we're going to go ahead and enter. In 2017, there were 100 air conditioners sold. So we're going to go ahead and put a dot right there. In 2018, there were 200 air conditioners sold. So we're going to put a dot right there. Okay. And in 2019, the company did really well and had 400 air conditioners sold that year. I'm going to go up to 400. Okay, so now we're going to draw this, connect this line. And as you can see, it's a curve. It's not a straight line, it's a curve. Okay, we're used to taking the average rate of change with a straight line. That's what we have as the slope. But in this case, we don't have a straight line. But we still can take the average rate of change. For example, let's look at 2018 and 2019. Even though we can't calculate exactly, at least not at this point, we can say between this year and between 2018 and 2019, we're going to connect those points in a straight line and find the slope of that line, and that'll give us the average rate of the air conditioners sold. Okay, so let's do that. We have our output is going to be 400 minus 200. Remember, this is just y2 minus y1 over 2019 minus 2018. Okay, so when we do that, we get 200 over 1, which is 200. Now 200 what does this mean, this 200? It means 200 air conditioners sold per year. All right, now were 200 conditioners exactly sold per year? No, not exactly. We have an average rate of change. So how we would say this is on average. Because let's say we wanted to know how many we sell in 2018 and a half, right? We can't completely stick to this. So we have to say on average, 200 ACs were sold per year from 2018 to 2019. So on average is the key there. All right, because as you can see, we're not on this line. This is the truth, this curved line. All we can say is on average, 200 air conditioners were sold per year. Okay, so let's keep going. You saw in the video about a difference quotient. I'm going to show you how we get there, okay? All right, so go ahead and draw this for me. We're going to call this X, all right? And we're going to draw a curve, make it kind of a really curvy curve so it's easier to work with. Okay. So if this is X, this right here is f of X. Okay. Now we're going to pick out a point over here somewhere. And what do we call that point? Well, this distance right here that we moved over, we're going to say this is h distance that we moved from here to here. So we're going to call this point x plus h. All right, so if this is x plus h right here, this would be f of x plus h. That's what that point would be. Okay, so let's say we want to find the average rate of change. Of course, we're looking at the line that goes between these 2 points. And if we were to find the slope of that line, we would take the outputs minus the inputs. Okay, so what is our outputs here? Here's one output, f of x plus h, minus this output, f of x. And then we have this input, x plus h, minus x. Okay, so let's write this out. F of x plus h minus f of x all over the x's cancel h. This is called the difference quotient. The difference quotient. Okay, all that is slope of that line, which is the average rate of change when our data is actually a curved line. Okay, so here's an example. First, I'd like to give you an example of an easy way to solve something and then to actually find the difference quotient. Okay, so here's an example. For f of x equal to x squared, find the difference quotient. I'm just going to call it diff q, okay, when x equals 5 and h equals 0.1. Okay, we're using this formula, and this is the easy way. We're going to put in h is 5. I'm sorry, x is 5 and h is 0.1. Okay, so we're going to go ahead and write f of 5 plus 0.1. That's x plus h, minus f of 5, that's f of x, where x is 5, over h, and h is 0.1. Okay, now if we were to actually evaluate this, I'm going to go over here, this would be 5.1. So we would put 5.1 squared because f of x is x squared. 5 plus 0.1 is 5.1, and f of that, here's our equation, is x squared. So we would square 5.1, and then what will we do? We're going to minus f of 5. If we put a 5 in there, we're going to get 5 squared, all over h, which is 0.1. Okay, let's continue to evaluate that. 5.1 squared is 26.01. 5 squared is 25, so we're going to minus 25 all over 0.1. And our answer is 10.1. Okay, now remember that answer, because now we're going to do the difference quotient in another way. Okay. That's my dog. Scratching the chair. Okay. So here we go. They're asking us to find the difference quotient. And you'll see problems like this on your homework. We said that the equation was f of x equals x squared. So instead of putting in the actual points, we're going to go ahead and find the general term for the difference quotient. And so this is going to become, because it's x squared and f of x plus h, we're looking at x plus h squared. We just put this into the input into this function. minus f of x. What is f of x? Oops. F of x is x squared, so we're going to minus x squared all over h. Okay, so we're just going to do some algebra here. This is x plus h times x plus h minus x squared over h. Okay, using FOIL, we have x squared plus 2xh plus h squared minus x squared over h. All right, we see that this x squared and this minus x squared cancel. All right, what else do we see? That's right, we see this h and this h and this h, so I'm going to factor out an h right here, 2x plus h. Notice h times 2x is 2xh, and h times h is h squared all over h. And the reason I did that is so we could cancel. It makes it easier. So what we have is all of this just equals 2x plus h. Now note, we were given that x equals 5 and h equals 0.1. Let's put that into this right here. We get 2 times 5 plus 0.1, which is 10.1. Exactly the same as before. So I just showed you 2 ways to evaluate it. On your homework, they will request that you go ahead and do this. Now, if you want to use the data table, you can go ahead and input the data into this, or as I showed you earlier. Okay, let's